Okay, so another thing I do to see if a gene mutation that one of my clients is carrying or not, which is why it takes me like a month to get through a set of clients, is I look to see where it's at in the protein and if I can reroute it around wherever it's at. So let me show you really fast. This is obscenely difficult to do on your phone. Let me just show you. I didn't feel like recording on my laptop. Go to Genomad or just Nomad, and you're going to type in your RSID right here. Okay, you should get something like this. It's gorgeous. We don't want the top of it unless you just want to look at this stuff. Okay, so this is going to tell you protein consequence. So this is the MTHFR. That RSID was for MTHFR C677T. It's one of the only ones I know by heart. And this is going to tell you that on amino acid 222, so when we count from like the beginning of the protein all the way down, we're going to count down to the 222nd. And on this site, alanine is going to change. Alanine is normal. That's like what's normally there. And then valine is going to be substituted out when you have the change of C to T. So that amino acid that's there, the nucleotide, should be a C. And when it's a T, that's when you have a mutation, this mutation. And you'll notice like some of these have like funny coding regions, right? It's because we've like renumbered this whole system like 3 times. Okay, then you're going to go to UniProt or UniProt, however you want to say it, and you're going to search for your enzyme. So don't search like RSID, RS number, right? Search for like MTHFR. It'll be like right above, back when we were on Genomad, it'll be right there. So just search for that. And then it's going to bring you to a big page with a bunch of different stuff. Just find enzyme, like then the symbol, and then human, because we got lots of different animals. So just click on this one. This looks horrible on a phone. This is like at the top, near the top somewhere, and it'll have like features or domains or something. You're just going to get close to it. So that's kind of in between. So we're at 222, right? This is 217. That's 228. So that's in either the FAD binding site or the substrate binding site. In this case, it's the substrate binding site. It's kind of in the middle. I can show you if you want to see it. I think I have a video on it. But it's kind of farther away from the binding site, but it does sit in between the two, mostly towards the substrate, which in this case would be folate, right? This is a little bit lower. And it's another table. You can find it pretty easily. So right at position 222, it'll tell you. I cut it off because it's horrible to use on your phone. But at 222, it even tells you that when you have this gene mutation, this enzyme now has a decreased affinity for the FAD cofactor, meaning that it just doesn't like hold its cofactor really well, and it needs that cofactor to work. And it has a 50% reduced activity and gives you the RSID, and then you could click on this and you get a bunch of publications. So for this, we also obviously need it to have its cofactor, right? So vitamin B2 would be a helpful support. And then substrate push would probably work with this. You could just give more regular folate, or you could just skip over the whole thing and give methylfolate because that's what it needs to work, or that's what it produces. Can you tell? How can you tell what it produces? Because up here in the top, it has catalytic activity. It'll tell you, read this first. It goes backwards. So that means you're going to start out with this stuff and you're going to make this stuff. So you're going to start out with this methylene tetrahydrofolate, and then you're going to go to methylfolate. So methyl tetrahydrofolate, or MTHF, which is the form of methylated folate that's in all of your vitamins. So that's why methylfolate jumps over this guy, is because that's what he produces. So you just like give your body it. So if you kind of learn the biochemistry and learn how these things work, it's actually really not difficult to kind of like biohack.